Let me show the path measurement. Let me change the language here too. Okay. Very simple setup. All you have to do, you have to have two Allegros. They can be connected to a mirror port, inline, on a tab. We don't care. What you do is both Allegros must see the exact same packets. So no WAN optimizer in between, no firewall. So for example, it's working very well on MPLS links. Once this setup is there, both Allegros must by any way should be able to communicate via the management port. And then the configuration is extremely simple. You use one device like this one, the DAFE here, as a master device, and it's called M1. And you only type in, okay, that's your peering device, the other Allegro, so 895E in my case here. I'll copy that because I need that to log in. And once I get a connection, yes, I'll just keep it running. Because what we see then, once this is configured and the measurement is running, we see the latency between the both Allegros. Very short explanation is we do CRCs on all packets, send from the one Allegro the CRC checksums to the other Allegro. And by that CRCs, we can correlate which connections are seen by both Allegros. Because there will always be some switches in between or routing that packets go different ways. So we have to see which connections go via both Allegros. Then we can do per connection, what is the latency between Allegro A and B and A per connection. Because we don't have some high sync clocks, we can only do the relative, the two-way latency. That's what we see here. But also, if we see a packet on Allegro A but not on B for a connection, we can be very sure that's lost in between. So we can see the loss between the client and the M1 or the opposite direction. And of course, the monitored packet rate. I can show that in bits per second, for example. And my demo setup here is between the two Allegros is a wireless bridge. And just showing you, if I generate some traffic now via this wireless bridge, you can see immediately in real time what will happen to that latency. And now we can see here that the latency goes for that wireless bridge goes up, and it's now something like 285 milliseconds, and it was before, it was something like 6 or 5 milliseconds in average. And by that method, you can easily see what is the packet drop rate, what's the monitored rate between two Allegros, and what's the packet loss rate. The good thing here is, if I now stop that transfer, I see the same here back in time. So I can easily, well, see, it will go down. Now it's very low again. We can just zoom into that time period where it was high. We can go to the dashboard and see, oh, yes, there was a big transfer. And in that time, it was very high. It's a very easy thing to set up, and it helps a lot to prove that either, for example, a WAN link or a Wi-Fi connection is good, or on the opposite, that the SLAs are not met. So you can see the packet drop, you can see the latency. We have some ISPs using that feature, especially to prove that, well, it's not their fault if a connection is bad. The big problem, for example, is you rent a 100 megabit MPLS line, but the physical connection is gigabit. So what happens to that MPLS if you send on average 100 megabit? Of course, you will send not all the time 100 megabit, you will send also gigabit peaks. And how to measure them, how to prove a client for an ISP, oh, your bandwidth was over the budget for a few seconds, for a few milliseconds. This is now very easy in combination with the path measurement. and, for example, the burst statistics, where you can see at that time what was the utilization of the link. And if you here change the utilization to the right speed, so here at 100 megabit, you can easily see what happened, how often was the link overloaded in that period, and prove that, well, if you overload a link, you must expect either drop packets or high latency because it's buffered. That's a very easy way to prove that it might be the network's fault or it might be just the user. On the opposite side, you can prove that the network is working very well in a passive way. So you don't have to do an active testing.